the universe. It stretches out before us, vast and largely unknown. For millennia, humanity has gazed at the stars, wondering about our place within this grand cosmic tapestry. We told stories, we charted constellations, we dreamed of reaching out. That dream is no longer just a dream, it's rapidly becoming our adventurous reality. We are living in a remarkable period, a true renaissance of space exploration, a time when the impossible is shedding its prefix. The pace of innovation is simply staggering, accelerating with each passing year, opening up new frontiers we once only read about in science fiction novels. This isn't just about planting flags anymore, it's about understanding our universe and our potential within it, a quest for knowledge that defines our species. Think about it. Just a few generations ago, space was an impenetrable barrier, a distant canvas for our imaginations. Now, we send sophisticated probes to the farthest reaches of our solar system. We have telescopes that peer back to the dawn of time, revealing the universe's baby pictures. Private companies are launching rockets with astonishing frequency, making access to orbit more common than ever before. This isn't just incremental progress, it's a paradigm shift in how we approach the cosmos. The year is 2025, and the sheer ambition of our current and planned missions fills me with an incredible sense of awe and excitement for what lies just over the horizon. We are boldly stepping into a future where humanity's reach extends far beyond Earth. This new space age is fueled by a potent combination of factors. There's the relentless curiosity that drives scientific inquiry, the desire to answer fundamental questions about existence. There's also the burgeoning commercial space sector, bringing fresh ideas, nimble approaches, and significant investment. International collaborations, alongside healthy competition, are pushing the boundaries of what's achievable. We are seeing technologies mature that were once purely theoretical, from revolutionary propulsion systems to advanced robotics capable of performing complex tasks in hostile environments. This convergence is creating a powerful momentum, carrying us towards a future where space is not just a destination for a select few, but an integral part of human civilization and progress. The significance of this era cannot be overstated. It's truly profound. We are not just exploring space, we are learning how to live and work there. We are developing the tools and techniques that could one day allow us to establish permanent off-world settlements, to tap into extraterrestrial resources, and perhaps even to find evidence of life beyond Earth. This journey outward is also a journey inward, teaching us more about our home planet and the delicate balance that sustains life here. The challenges are immense, of course, but so is the human spirit of exploration. We are on the cusp of extraordinary discoveries, and every launch, every experiment, every new piece of data brings us closer to a future that is truly cosmic in scale. The quest for space is no longer a two-horse race, a relic of the Cold War era. Today, the cosmic arena is a vibrant, bustling place filled with numerous players, each bringing unique strengths and ambitions. We see established government agencies like NASA, with its decades of pioneering experience, continuing to push the envelope with missions to the Moon, Mars, and beyond. They are the giants whose shoulders many now stand upon, but they are not alone. Emerging space powers from countries across Asia, Europe, and the Middle East are making significant strides, launching their own satellites, developing independent launch capabilities, and contributing valuable scientific research to the global effort. This diversification is a fantastic development for all of humankind. Then there are the commercial titans, companies like SpaceX and Blue Origin, who have fundamentally disrupted the launch industry and are now setting their sights on ambitious goals like lunar bases and Martian cities. Their innovative spirit, rapid development cycles, and focus on reusability have dramatically lowered the cost of accessing space, opening doors that were previously unimaginable. These companies are not just contractors, they are visionaries, driving a new model of space exploration that blends private enterprise with grand, exploratory dreams. The synergy between government agencies and these private ventures is creating a powerful ecosystem for innovation, accelerating our collective journey towards the stars and making space more accessible. International collaboration remains a cornerstone of many major space projects. The International Space Station, a testament to what nations can achieve when they work together, continues to be a hub for research and a symbol of peaceful cooperation in orbit. Future missions, particularly those aimed at establishing a sustained human presence on the Moon and eventually Mars, will almost certainly require even deeper levels of international partnership. Sharing resources, expertise, and the inherent risks of space exploration makes a great deal of sense. After all, the cosmos belongs to no single nation. It is the shared heritage and future of all humanity, a common ground for aspirational endeavors. However, this burgeoning activity also brings with it a new form of competition, sometimes referred to as a new space race. Nations and corporations are vying for strategic advantages, for access to resources, and for technological supremacy. While competition can be a powerful motivator for innovation, it also introduces complexities related to space traffic management, debris mitigation, and the responsible use of celestial bodies. Navigating this complex landscape, balancing national interests with the collective good, will be one of the key challenges of this new space age. The future requires not just technological prowess, but also thoughtful diplomacy and a shared vision for a sustainable and peaceful presence beyond Earth. One of the most persistent, surprisingly troublesome challenges of exploring worlds beyond Earth is something seemingly mundane: dust. But this isn't your ordinary household dust. Lunar regolith, the fine, abrasive powder that covers the moon, is a nightmare for astronauts and equipment. It clings to everything, wears down seals, clogs mechanisms, and can even pose health risks if inhaled. The Apollo astronauts learned this firsthand, their spacesuits and landers caked in the stuff after every moonwalk. As we plan for longer stays on the moon, and eventually Mars where the dust is similarly problematic, finding effective ways to combat it is absolutely critical for mission success and astronaut safety. Enter a clever piece of technology called the Electrodynamic Dust Shield, or EDS. Imagine a surface that can actively repel dust particles, almost like magic. That's essentially what an EDS does. It works by creating an oscillating electric field across a surface embedded with a series of electrodes. This field charges the dust particles and then uses electrostatic forces to lift them off and transport them away from the protected area. It's an elegant solution that doesn't require wipers or fluids, which can have their own set of problems in the harsh vacuum of space or on frigid planetary surfaces. This technology is not just a theoretical concept, it's being actively tested and refined. NASA's Blue Ghost Mission 1, which successfully landed on the moon in Mare Crisium back in March 2025, carried an EDS experiment among its payloads. This mission was crucial for demonstrating the shield's effectiveness in the real lunar environment. The data gathered is invaluable, helping engineers understand how well the technology performs under actual conditions, how much power it consumes, and how durable it is. Similar technologies are also being developed for Mars, where the reddish, iron oxide-rich dust presents its own unique set of challenges. Mitigating dust is essential for everything from keeping solar panels clean and efficient to ensuring the longevity of habitats and scientific instruments on these alien landscapes. The implications of mastering dust mitigation are far-reaching. It means our future lunar bases could have cleaner habitats, more reliable equipment, and healthier environments for astronauts. Rovers could explore for longer periods without their moving parts grinding to a halt. Scientific instruments could gather clearer data, unmarred by pesky coatings of fine particles. For Mars, the stakes are even higher, given the longer mission durations envisioned. The development of robust dust mitigation systems like the Electrodynamic Dust Shield is a vital enabling technology, a seemingly small detail that has a massive impact on our ability to live and work sustainably on other worlds. It's a perfect example of how ingenious engineering can overcome the subtle but significant obstacles the cosmos throws our way. For decades, space travel has been synonymous with the controlled fury of chemical rockets. These magnificent machines, burning vast quantities of propellant to generate thrust, have successfully carried us to orbit, to the moon, and to the distant planets of our solar system. They are a testament to human ingenuity. However, chemical rockets have their limitations, particularly when it comes to specific impulse, a measure of their efficiency. For ambitious future missions like rapid transits to Mars or voyages to the outer solar system, we need to explore and develop even more advanced propulsion methods. The next great leap in space exploration will be powered by new ideas, pushing beyond traditional fire and smoke. One of the most promising candidates is nuclear thermal propulsion, or NTP. Instead of chemical reactions, NTP systems use a nuclear reactor to heat a propellant like liquid hydrogen to extremely high temperatures. This superheated gas is then expelled through a nozzle to produce thrust. The key advantage of NTP is its significantly higher specific impulse compared to chemical rockets, meaning it can generate more thrust for a given amount of propellant, or achieve the same thrust with less propellant. This could translate into shorter travel times to Mars, reducing astronauts' exposure to cosmic radiation and the psychological stresses of long-duration spaceflight, making the journey safer and more efficient. Then, there's the realm of electric propulsion, which includes technologies like ion thrusters and Hall thrusters. These systems use electric power, often generated by solar panels, to accelerate a propellant, typically an inert gas like xenon, to very high speeds. While the thrust produced by electric propulsion is very low, you wouldn't use it to launch from Earth. It is incredibly efficient. Over long periods, these gentle but persistent pushes can accelerate spacecraft to very high velocities, making them ideal for deep space missions, satellite station keeping, and even cargo transport to destinations like the Moon or Mars. We are seeing continuous improvements in the power and lifetime of these electric thrusters, making them increasingly versatile. Furthermore, the search for greener and more sustainable propellants is gaining momentum. Traditional rocket fuels can be highly toxic and difficult to handle. Researchers are exploring innovative alternatives, including water-based propulsion systems, which offer advantages in terms of safety and potential for in-situ resource utilization. Imagine refueling your spacecraft with water ice mined from the Moon or asteroids. Iodine-based electric propulsion is another exciting development, as iodine is denser than xenon and can be stored as a solid, simplifying spacecraft design. These advancements in diverse propulsion technologies are crucial for unlocking the next phase of space exploration, enabling faster, more efficient, and more sustainable journeys across the cosmic ocean. Section 5. Building among the stars. The promise of in-space manufacturing. Imagine needing a critical spare part for your lunar habitat or a specialized tool for a Mars rover. But Earth is millions of miles and months away. This is where the revolutionary concept of in-space manufacturing, or ISM, comes into play. Instead of launching everything we need from Earth, which is incredibly expensive and time-consuming, ISM envisions creating components, structures, and even entire systems directly in space using local resources or materials brought from Earth in a more compact form. This capability is not just a convenience. It's a fundamental enabler for long-term human presence and sustainable exploration beyond our home planet, truly a game-changer for how we operate off-world. A cornerstone of ISM is additive manufacturing, more commonly known as 3D printing. Space-based 3D printers could use various materials from plastics and metals to ceramics and even processed lunar or Martian regolith to fabricate items on demand. This means we could print tools, replacement parts, medical devices, and even segments of habitats as needed. The benefits are enormous. Reduced reliance on Earth-based supply chains, lower launch mass, since raw materials are often more compact than finished goods, and the ability to rapidly prototype and iterate designs in the actual space environment. The global in-space manufacturing market is projected to see substantial growth, reaching over $10 billion by 2032, indicating strong confidence in this transformative technology. Beyond 3D printing, ISM encompasses other advanced techniques like microgravity casting, welding, and assembly of large structures that would be too cumbersome or delicate to launch fully assembled from Earth. Think of large solar arrays, expansive antenna reflectors, or even sections of spacecraft being constructed in orbit by robotic arms or astronaut crews. North America currently holds a significant share of this burgeoning market, but interest and investment are growing globally. Startups like ASPAX, developing climate-controlled boxes for ISM, and ArcSpace, with its orbital testbed operations platform, are pushing the boundaries of what's possible, demonstrating the vibrant innovation occurring in this critical sector of the space economy. The long-term vision for in-space manufacturing is truly transformative. It promises to reduce the cost and complexity of space operations, enhance mission resilience by enabling on-demand repairs and fabrication, and ultimately support the development of a self-sustaining space economy. As we establish permanent outposts on the Moon and plan for human missions to Mars, the ability to build what we need, where we need it, will be indispensable. In-space manufacturing is not just about making things in space. It's about fundamentally changing our relationship with space, turning it from a place we visit into a place where we can sustainably live and work, building our future one layer, one component at a time. Section 6. Our robotic trailblazers, exploring and building in the void. As humanity extends its reach further into the cosmos, we won't always be able to go there ourselves, at least not initially or for every task. This is where space robotics plays an indispensable role. These sophisticated machines are our eyes, ears, and hands in environments too dangerous, too distant, or too delicate for direct human intervention. From deploying and maintaining satellites in Earth orbit to exploring the enigmatic surfaces of distant planets and moons, robots are the unsung heroes, the tireless pioneers paving the way for future human explorers. The market for space robotics is substantial, projected to grow from around $5.69 billion in 2025 to over $8.47 billion by 2033, highlighting their increasing importance. Consider the crucial tasks robots perform in orbit. They assist with satellite deployment, grappling newly launched spacecraft, and gently nudging them into their correct positions. They undertake complex maintenance and repair missions, extending the lives of valuable assets and even rescuing satellites that might otherwise be lost. Think of robotic arms on the International Space Station, or dedicated servicing vehicles designed to refuel, repair, or upgrade orbiting platforms. Startups like Inspecity are developing robotic systems such as RAMA, or Robotic Assembly and Maintenance Arm, specifically for these in-orbit repair and assembly tasks, showcasing the innovation driving this field forward. These capabilities are vital for the sustainability of our growing orbital infrastructure. On planetary surfaces, robotic explorers like rovers and landers have revolutionized our understanding of worlds like Mars and the Moon. Equipped with advanced sensors, drills, and analytical instruments, these tireless emissaries conduct geological surveys, search for signs of past or present life, and collect samples for potential return to Earth. Future missions will see even more sophisticated robots, perhaps working in teams, capable of greater autonomy and able to access more challenging terrains. For instance, Evolunar's Lunadrone concept aims to enhance lunar exploration capabilities, demonstrating the push towards more versatile and capable robotic systems for planetary science and resource prospecting on celestial bodies. The synergy between humans and robots will be key to future space exploration. Robots can perform precursor missions, scouting locations, and testing technologies before humans arrive. They can undertake routine or hazardous tasks, freeing up astronauts for more complex scientific research or critical decision-making. In-space assembly and construction, as we discussed with in-space manufacturing, will heavily rely on advanced robotics to build large structures and habitats. As artificial intelligence and machine learning continue to advance, the autonomy and capabilities of these space robots will only increase, making them even more indispensable partners in our cosmic journey, our trusted mechanical companions in the great unknown. Section 7. Catching Sunbeams in Orbit, the Future of Space-Based Solar Power. Our civilization is hungry for energy, an ever-increasing demand that strains terrestrial resources and impacts our planet's climate. What if we could tap into an abundant, clean, and virtually inexhaustible source of power, available 24/7, regardless of weather or time of day? This is the grand vision of space-based solar power, or SBSP. The concept involves placing large solar panel arrays in orbit, typically in geostationary orbit, where they can continuously collect sunlight. This collected solar energy would then be converted into microwaves and beamed wirelessly to receiving antennas or rectennas on Earth, where it would be converted back into electricity and fed into the power grid. The advantages of SBSP are compelling. Unlike ground-based solar farms, orbital solar collectors are not affected by nighttime, cloud cover, or atmospheric absorption, allowing them to generate power almost continuously and at a much higher intensity. A single SBSP system could potentially generate gigawatts of power, comparable to large conventional power plants. This could provide a significant source of baseload clean energy, helping to reduce our reliance on fossil fuels and mitigate climate change. The global investment in SBSP reached $370 million in 2024, and the market is projected to grow significantly, reaching an estimated $4.7 billion by 2030 and $6.8 billion by 2040, signaling growing global interest. Of course, there are significant technological and economic challenges to overcome before SBSP becomes a widespread reality. Launching the massive structures required for these solar arrays into orbit is a major undertaking, though the falling costs of launch services are making this more feasible. Developing efficient and safe wireless power transmission over vast distances, ensuring the beam doesn't harm birds or interfere with communications, is another critical area of research. Furthermore, the assembly and maintenance of these enormous orbital platforms will require advanced robotics and in-space manufacturing capabilities. Startups like Womatics, focusing on AI for solar power forecasting, and Source developing space energy products, are contributing to solving pieces of this complex puzzle. Despite these hurdles, the potential payoff of space-based solar power is so immense that numerous countries and private entities are actively pursuing research and development efforts. Japan, China, the United States, and the United Kingdom all have active SBSP programs or initiatives. As technology matures in areas like lightweight solar cells, efficient power beaming, and autonomous robotic assembly, the dream of harvesting the sun's energy from space could move closer to reality. If successful, SBSP could revolutionize our global energy landscape, providing a clean, continuous, and abundant source of power to meet the needs of a growing world population, truly a stellar solution to our energy needs. Section 8. The new space mavericks, startups fueling cosmic innovation. While established government agencies and large aerospace corporations continue to play vital roles, a significant portion of the electrifying innovation we're witnessing in the space sector today is being driven by a dynamic ecosystem of startups. These agile, often highly specialized companies are tackling specific challenges, developing niche technologies and bringing fresh perspectives to the cosmic frontier. They are the nimble speedboats darting between the supertankers, rapidly iterating on ideas and pushing the boundaries of what's possible. From novel propulsion systems to advanced data analytics, these new space mavericks are undeniably accelerating the pace of space exploration and commercialization, injecting vitality into the industry. Consider the sheer breadth of areas where startups are making their mark. In defense and space security, companies like Bitresus are focusing on cybersecurity for space assets, a critical need as our reliance on satellites grows. For in-space manufacturing, ASPACs and ArcSpace are developing platforms and environments for building things off Earth. In satellite data analytics, SpaceEyes is using AI for predictive insights, while Zytra focuses on space-qualified data processing. These are not just minor improvements, they are foundational technologies being pioneered by focused entrepreneurial teams. This diverse innovation landscape is crucial for building a robust and resilient space economy for the future. The propulsion sector is another hotbed for startup activity, with companies like ISRO developing green in-space propulsion systems, and Cosmo B working on advanced electric propulsion. In the realm of space robotics, Inspecity and Evolunar are creating robots for in-orbit servicing and planetary exploration, respectively. For the ambitious goal of space-based solar power, Womatics and Source are contributing specialized technologies. Even the challenge of space debris is being addressed by innovators like Andraste Group and Delta Infinite. And when it comes to actually building the hardware, Spacelab is creating space-qualified 3D printers, while Abraspace is 3D printing rocket engines. This entrepreneurial spirit is truly permeating every facet of space technology. This surge in startup activity is fostered by several factors: decreasing launch costs, the availability of venture capital, advancements in miniaturization and enabling technologies like AI, and a growing global talent pool passionate about space. These companies often operate with a lean startup mentality, allowing them to pivot quickly and take risks that larger organizations might shy away from. They are not just suppliers, they are becoming key partners, collaborators, and even competitors, driving the entire space industry forward. Supporting and nurturing this startup ecosystem is essential if we are to fully realize the potential of this new space age, harnessing their creativity to solve the grand challenges of cosmic exploration. Section 9. To Infinity and Keep Going, Our Unfolding Space Destiny, and a Small Request. We stand at a truly remarkable juncture in human history, a moment where our reach is finally beginning to match our cosmic aspirations. The future of space technology, from 2025 and far beyond, promises a continued acceleration of discovery and capability. We've explored the incredible advancements in dust mitigation, the revolutionary new propulsion systems that will carry us further and faster, and the game-changing potential of manufacturing and building directly in the void. We've seen how robotics will extend our senses and our abilities, and how we might one day beam clean energy down from orbit. This is not science fiction. This is the trajectory of human ingenuity, unfolding before our very eyes. The trends are clear. Space is becoming more accessible, more commercial, and more integrated into our global infrastructure and economy. The ongoing development of reusable launch vehicles will continue to drive down costs. Miniaturization will allow us to pack more capability into smaller, more affordable satellites. Artificial intelligence will enhance the autonomy of our robotic explorers and the efficiency of our space operations. The global space race, now a multipolar endeavor involving nations and private companies alike, will continue to spur innovation, even as it necessitates careful management and diplomacy to ensure peaceful and sustainable development. The journey ahead is filled with both immense challenges and even greater opportunities for humanity. Continuous innovation is not just desirable, it is absolutely essential. The problems we aim to solve, establishing a permanent human presence on other worlds, searching for life beyond Earth, understanding the origins and fate of the universe, are among the most profound and difficult we can tackle. They demand our best science, our most creative engineering, and our most unwavering commitment. The insights gained from space exploration also provide invaluable perspectives on our own planet, helping us to address critical issues like climate change, resource management, and global connectivity. Investing in space technology is investing in the future of humanity, both on Earth and among the stars. The story of space exploration is our story, a testament to our curiosity, our resilience, and our unyielding desire to explore. The technologies we are developing today will shape the lives of generations to come, opening up new worlds and new possibilities. It's an epic adventure, and it's happening right now. If you're as thrilled by this cosmic journey as I am, and want to stay updated on the latest breakthroughs in space technology and exploration, then please do subscribe to this channel and give this video a thumbs up. Your support helps us continue to share the wonders of the universe and the incredible human endeavors to understand it. Keep looking up,